both the concentration of the reactant CH3Br and the concentration of the nucleophile KH. The halogen atom connected to the benzene is very less reactive. That's what we have seen, because it is in resonance. It requires partial double bond character, and we had seen that there is an inversion of configuration in SN2. And now we also discussed that suppose if there is a highly branched substrate, highly branched reactant, then what substitution is going to happen? SN1. Okay, substitution nucleophilic unimolecular. SN1, Ibrahim, as the name indicates, two things don't get involved in SN1, right? Just one
Yes,
of
sir.
the
Unimolecular.
molecule. Yeah, unimolecular. One molecule of the reactant. That we have seen, right? SN1 reaction. And how one reactant itself can react, that's the question. So that reactant undergoes slow ionization, leading to the formation of a cation, and then cation is attacked by nucleophile in the next step. So it is a two-step mechanism. Okay. And definitely that cation formation is a difficult step, and if the cation formed is going to become more and more stable, the rate or the speed of SN1 is going to increase. The cation formed in the reaction can be stabilized by resonance. What do you mean by this? Just in your words, can you explain? Yeah,
What, sir?
what do you mean by this resonance? Why the Cl atom connected next to benzene, not on the benzene, can be removed so easily in SN1 reaction?
So because of less steric hindrance, I think.
No, steric hindrance will cause. I'm comparing these two. Okay. I'm telling this VR can come out very easy. Because rate is fast, and this for this the rate is slow. Right? Why? What's the reason?
What can be the reason, sir? I don't know.
Yeah, Jasleen, good evening. So we had just started with the recap of the last class, and we are discussing it. Right. So I was in the last class. I discussed that I was discussing with Ibrahim that why this was undergoing faster reaction, and this was slower. What could be the reason? Okay, the reason is, though both are Br, CH2Br, both groups are big. Benzene is also a bigger group. This cyclohexane is also a bigger group. So why the reaction of A proceeds with a faster rate, while reaction of B proceeds with a slower speed? What could be the reason? What could be the reason responsible for for controlling the rate of SN1 reaction? Okay, the reason is stability of carbocation. Benzylic cation is stabilized by resonance. Got it? Is it clear? So what is resonance? What you know about it? Ibrahim and Jasleen, can you tell me just few words what it is actually? Resonance. What it is about? Tell me. Yeah. Ibrahim, Jasleen. Resonance is basically this cation, the positive charge. It can take away the electrons. Which type of electron? Pi electron from the benzene ring. So this pi bond was there. It moves out, and plus charge is coming on this carbon atom. Is it clear? This plus charge can pull another pi bond like this one, the lower pi bond like this. Okay, and you have a plus charge over here. This can pull the subsequent pi bond, and you have a plus charge here and this. So what by doing this? This is known as resonance, and by doing this, I am trying to explain that the cation formed in the A, that is a benzylic cation, is very much stable because the positive charge spreads, okay, by resonance. This phenomena is known as resonance. And a positive charge get distributed, it becomes stable, and it can form more quickly. Is it clear or not?
Yes, sir.
Okay. So wherever the cation is stable, the speed of SN1 is going to be faster. Rate or speed, it is one and the same thing of SN1 is directly proportional to the stability of carbon. Carbocation can be stabilized by resonance. Got it? So can you tell me what is the rate of SN1 reaction? Rate of SN1 reaction with yes, Zainab, good evening. Am I audible?
Yes, sir.
Okay, I was explaining the substitution reaction and SN1 reaction in which the group come out before the attack of the nucleus. And I just explained that if the group come out before the attack, it leaves behind a carbocation. And wherever the carbocation is stable, the reaction, it can form very easily, and the reaction is going to be very fast. Okay, so what I told Jasleen and Ibrahim, that rate of SN1 is directly proportional to the stability of carbocation. Okay, So I was asking, this is benzene, and how a benzene can stabilize a cation. In one word, you can say it is by resonance, and this is the whole diagrammatic approach of showing how that plus charge is pulling the pi electron of the benzene that is coming here at the ortho position. Then it is coming at the para position. You can see. Okay, and how the plus charge is getting distributed and becoming stabilized, right? So rate of SN1 is directly proportional to the stability of carbocation. And now all three of you, Jasleen, Ibrahim, and Zainab, you can try this problem. What will be the speed of SN1 reaction for these three reactants? Ibrahim, Jasleen, Zainab, I hope A is more, B is more, Jasleen or C is more. Look, there are two things. One is that there is a lot of crowding, but crowding is a matter of concern in SN2. In SN1, it is not the matter of concern because the nucleophile is not coming directly. Is it clear? So you don't have to look for the crowding. Don't think that these are bigger group, how the nucleophile is going to come in. Okay, because in SN1 reaction, nucleophile doesn't come directly. Okay, first whatever is given to you, that only you react. Okay, you remove the halogen first. So halogen, is it same or different in A, B, and C? A halogen
It's
atom is this. It's same. So Cl minus can come out with. So Cl minus of A, Cl minus of B, and C, all three are same. So now the whole responsibility comes to the cation, the C plus, which is left behind. And C plus is actually a benzylic cation because it is adjacent to the carbon atom having the benzene ring. Okay, just like this. So if a cation can form easily, it will let the Cl minus go away very quickly. Okay, the cation will say, okay, leave. Immediately I can become stable by doing resonance. Are you getting my point? And if a cation is stabilized by resonance, it can form very easily, and the speed of SN1 is going to be fast. Clear or not?
Yes, sir.
Jasleen and Zainab. Zainab, is it clear?
Yes, sir.
Jasleen. So now Cl minus is coming out. You are having which cation? I am going to write it in a shortcut manner. pH. pH is the phenyl ring. Got it? CH2 plus. This is pH. C plus pH. And this is pH. Don't bother about the crowding. That is in SN2. In SN1, bother about the stability of the carbocation. Okay. So carbocation, it is more stable. It is like this. Why more stable? Because this plus charge is offered electrons from three of the benzene ring. There are three sides you have a benzene ring and they can offer the electrons by resonance like this. This is just one benzene. So imagine you can have one more and one more. What will happen to the cation? Cation is being offered by pi electrons from the benzene ring from three sides. So cation will get stabilized by resonance. So which cation is more stable? This is more stable. And because it is stable, it can form very easily, very quickly, and the speed is going to be fastest for C. Is it clear or not?
Yes, sir.
So both are mutually exclusive. It means both are opposite. In SN2, you bother about the crowding. If you have more bigger groups, they will not let the nucleophile come in. Nucleophile is also coming in the same step, so we should bother whether it can come and join itself to the carbon or not. But in SN1 reaction, we don't have to bother about the size of the groups because the nucleophile is not coming directly. It is unimolecular reaction. First, you let the leaving group go out. First, you form a cation. So you should bother about the stability of the cation. And if the cation is connected to electron donating benzene rings or pi bonds or lone pairs are there which can stabilize the cation, that cation can form very easily and the speed is going to be very high. So I hope this is clear. Rate of assembly is directly proportional to the speed of SN1 is directly proportional to the stability of the carbon. Got it? Right?
Yes, sir.
Next is your in SN2, if you remember, inversion was happening because the group was coming directly and in one step you were doing all the things. So nucleophile was coming from backside. So SN2 inversion of configuration means the attachment of nucleophile will be from the backside, side opposite to the group which is going out, leaving group. Okay. In SN1, there is no such compulsion. SN1 proceeds via carbocation. And this carbocation, if you look at the shape of the carbocation is a flat. When you have plus charge, this is the p orbital, which is empty. That's why you have a cation. And this is basically the carbocation. It is like this. All the three bonds become like this. So the nucleophile now can come in from both the sides. Okay. So you get what does this mean? Can you explain me? What does this mean? What do you mean by racemic mixture? Ibrahim, Jasleen, Zainab, tell me quickly.
Sir, racemization. It means like when like two substances or two different compounds are obtained and they're like mirror images of each other. So like in one compound, if all the if all the if all the halogen groups and the methyl groups are on left, so in the other it will be on the right. That's how it is.
Yes. So suppose I will take an example. Suppose if you have a CH3, okay, this you are having hydrogen, or take the phenyl group. Phenyl is coming towards us. It is above the plane of the paper. And this is going behind the plane. H. And you have Br. And you react it with water. Okay. SN1. SN2 can't happen because it is too big. Okay. And phenyl promotes SN1 reaction. So I'm asking whether the OH is going to get attached from the same side where the from where the Br is attached, or from the opposite side to that of the Br, or both options, same side or opposite side, both options can happen. That you need to tell me. So let me draw option A. Option A, I will replace the Br with OH. Okay. Option B, I will just invert it, right? Or I will just put the Br on this side or the OH on this side. Or what could be the answers? Will you get only A? If you get only A, what you will call? I have replaced the Br by OH. Got it? So if you get only option A, what kind of observation you are getting? Will it be called as inversion or retention? Just tell me quickly. If you get only A, is it the retention or the inversion? Only A.
The retention. If we
Yeah,
get only A.
retention means on the same side where the leaving group was there. Retention means or you are getting inversion. Inversion means you flip the bonds on the other side and you connect the nucleophile from the side opposite to Br. Inversion means only B is formed. And suppose if both can form in 50-50 amount, equal amount, that is called racemization. Racemization is equimolar or 50% A, 50% B. Got it? So Zainab, Jasmine, tell me quickly what you are going to get the product. In SN1, what happens? Zainab, are you getting it or not?
Yes, sir.
In SN1, because the leaving group completely detaches itself from the carbon, leaving a plus charge on the carbon, that plus charge on the carbon has a flat, 3 bonds become flat like this, okay, just like the blades of a fan, okay, they become flat. And once they become flat, now the OH groups come in the next step. So it can come from the top, it can come from the bottom, or if you draw it like this, the OH can get attached on this side or this side. So that lead to equimolar mixtures of both the compounds. Are you getting my point? So if this is SN1, the answer should be racemization or racemic mixture is obtained. I hope this is clear to all of you.
Yes.
Jocelyn, Zena,
Yes, sir.
right? Okay, so this is what is happening in your SN1 reaction. Okay, SN1 actually is racemization. SN2 is basically SN2 is inversion. Okay, SN2 inversion. Why SN2 inversion happens? Can you, if somebody asks you what will you write in just one word statement, why inversion takes place in SN2 reaction? Can you tell me? Because SN2 reaction is just a single step. Both the molecules would collide and the nucleophile, and in one step you need to complete all the reaction, all the steps. That is just one step. So you need to bring in a nucleophile from the opposite side, back side, and leaving group depart from the other side. That's why you see the leaving group, the nucleophile getting attached from the back side or the opposite side. Okay. This is also written like this, plus minus. One is dextrorotatory, another is levorotatory. Got it? Is it clear? If you put it in, if you pass the light through it, one will rotate the light in the clockwise direction, another will the anti-clockwise. So this is the sign of rotation of light. Next reaction is elimination reaction. What do you mean by elimination reaction? What does this mean? The word is very simple, all of you know it.
The removal of a compound from a
Yeah, removal
removal
of
of
any one group or two groups.
any one group. Yeah.
Because if you remove one group, yeah. So what will happen to the bond? Are you getting my point? So you do not remove only one group, you remove two groups. So there is a halogen and there is a H. Okay. You remove H plus and minus X minus. Okay, you remove both of them. Okay. Or I can write it like this, minus HX. For example, if this is HNCl, you remove HCl from the adjacent carbon. So it is the removal of two groups. Why two groups? Because once this X come out, the bond is free. This H is also, these bonds, the valencies can be satisfied if these both the bonds get attached to themselves, forming a double bond. Is that clear or not?
Yes.
Right. So you are having this double bond, okay, and this elimination is known as one-two elimination, because the adjacent carbon are numbered as 1 and 2, or it can be called as alpha beta elimination. Alpha beta means the halogen and the hydrogen are removed from the adjacent positions. Is it clear? And these bonds join among themselves, leading to the formation of a double. Right? So you have this as a product, alkene. Alkenes are formed. Is it clear or not? Next is
Yes.
how do you remove? How do you eliminate the HCl? Okay. How do you remove? Let me take one example. If I take ethyl bromide or bromoethane, okay, and if I carry out the elimination, if I remove HBr, what is happening? What is being removed? I write it on the arrow minus HBr. So you are having CH2 and CH2. What will happen to these two bonds? They will join among themselves. But what is the reagent which is to be used for elimination reaction? Can any one of you tell me? If you remember, HBr is an acid. So to remove acid, you need to take a base. And because you are breaking the bonds, you need heat. Is it clear or not? Strong base and heat. And this strong base is none other than the KOH. KOH is white solid. Pellets are there that they are white in colored. But to do the reaction, solid can't react. You need to dissolve it. Okay. You need some solvent where you can make a solution. So dissolution is taking place in alcohol. And this is also known as alcoholic KOH. Alcoholic KOH. It is the base mixed in alcohol solution. Why alcohol solution? Okay, so you take KOH, KOH eliminates the B and it forms a salt, KBr and H2. So this is the complete products, but nobody bothers about these two products. If somebody is asking, then only you should write, otherwise you should mainly bother about the organic product. Is it clear or not? Listen. Right? Clear or not?
Yes.
Alcoholic, suppose, so why not? Why alcoholic? Is there any other form? You need to dissolve KOH. KOH is a white solid. You can mix into water also. If something is mixed into water, that is known as aqueous. Okay. Suppose if you take aqueous OH, water you can't heat much, and water makes the KOH less reactive. So elimination is not going to happen. Elimination is not going to happen. The elimination is not going to happen. Then what is going to happen? Substitution can happen. Because this is mild form of base. Substitution is going to happen. How come substitution? Okay, the OH minus is a base. Actually, it is a nucleophile also. So it can get directly attached to the carbon atom bearing the bromine, and the bromine can be pushed out. So substitution, basically you will get this. This is the product. And now how elimination can happen? Elimination can happen if the same base, instead of carbon, breaks away the hydrogen. These electrons form a double bond and the Br comes. So the OH minus, I will write it separately. Okay. In the above case, it is acting as a base. It is breaking apart the H, forming a double bond. In the second reaction, the OH minus is acting in as a mild reagent because you have mixed it into water, and it is causing substitution by doing SN2 reaction. Is it clear? So KOH aqueous is the mild form that will replace Br by OH. Can you remember that? Zainab, Jasleen, Ibrahim, tell me.
Yes, sir.
And what happens with if you mix the KOH or the base with alcohol? It becomes very strong. Okay, because alcohol doesn't cause much hydrogen bonding. So KOH become very strong, and it causes the two groups H and Br getting removed and double bond being formed. Is it clear or not? Right? So this you must know, very, very, very important. When you want to do the elimination, when you want to do the substitution reaction. I hope it is clear to everyone. Got it?
Yes, sir.
Okay. Next is, suppose let me take some more examples, direct examples. And elimination always require heat. That also you need to know, because you are breaking two groups, you require more heat. Okay. Suppose if I react it with water, and if I react it with KOH mixed into C2H5OH. Sometimes people get confused that what it is. It is alcoholic KOH. Got it? KOH mixed in alcohol with heat, which is represented by delta. Okay, what all we can get? This is simply water. Zeno, this is simply water, which is a very weak base. Got it? So what can happen with the water, or what cannot happen? And this is a strong base. So can you explain me? Zainab, Jasleen, Ibrahim, tell me quickly. Yeah, this is what can happen. Ibrahim, Jasleen, tell me. What can happen? In the first case, is it the vigorous condition or just a mild condition? With water, it is the mild condition. You have not taken any heat. You have not taken any strong. Water is a neutral substance. Okay, so substitution is going to happen. And Br will be replaced by OH. Zainab, is it clear or not? OH.
Yes.
Okay. And Ibrahim, what will happen in the next reaction?
With KOH, the bromine group will go.
Yeah, only the bromine will go. There is a heat also. Look,
Oh, okay. So,
whenever you see
substitution
this
happen.
sign, no substitution occurs in the mild condition without heat, with weak base. Okay.
Oh, okay, okay, yeah. So, sorry, elimination happen.
Strong condition, two groups will be removed.
Mhm.
Okay. Not only Br, H and Br from the adjacent position. Okay, so that is elimination. Is it clear, Jesslyn?
Yes.
So we are going to end up with a double bond. Okay. And somebody if you ask what are the other product, KBr and OH2. But normally people are more bothered about the alkene. Is it clear? This is elimination reaction. Now, suppose we have two bromobutane. This is two bromobutane. So all of you are, I hope, satisfied with this. Okay, two bromobutane, right? And if I take KOH alcoholic, okay, heat, what is going to happen? Alcoholic KOH and heat, elimination of H and Br from two adjacent carbon atoms. Is it clear? Ibrahim, Jasleen, Zainab.
Yes, sir.
So this is the position where the Br is attached on the second position. The H will be removed from the first position or from the third position. Now, because we have hydrogen on both the sides, we have two options available, either to form double bond this side or that side. Okay. So, which is the major product? What do you mean by major product? The main product, which is formed in larger percentage. Is it clear or not? Which is the
Yes.
major product? Can you tell me? And there is a rule. Just like addition, there is a Markovnikov rule. In elimination also there is a rule. Okay. Major, this is the double bond. And how many carbon containing groups are there? One alkyl group. Okay. And this is the double bond. How many carbon containing groups are there? Jasleen and Zainab on this double bond, doubly bonded carbon, you have two groups, two methyl groups. Okay. So that is having two groups on the either side of it. Got it? And there you had just one group. Are you getting my point? That is mono substituted and this is di substituted. Right? Is it clear? Mono substituted means one alkyl group and di means two alkyl group on both the side, or you can have three groups also. So this is more branched. This is more branched alkene. Okay. More branched alkene is the major product. And this is known as ZZ. Is it clear or not? ZZ alkene is actually out of, it is not that only the two bromo is, or the butene is the ZZ alkene. Got it? Not like that. So in elimination, if there are two products being formed, okay, one is actually with a double bond in the middle with more number of alkyl group. So alkene with more number of alkyl group is known as ZZ alkene, and that is going to be the main product. It is formed where the double bond is formed in the middle. Okay, and alkene with less number of alkyl group. Alkene with less number of alkyl group is known as often alkene. Where the double bond is pointing outward. So whenever there are options, you are going to put the double bond in alpha beta elimination. Okay, this is alpha beta or just beta elimination. ZZ alkene is going to be the major product. And Hoffman alkene is going to form in less amount. Okay, let me give you some more examples so that you can make out which is ZZ alkene and which is Hoffman alkene. Okay. This is cyclohexane. When you get a cyclohexane where the double bond is inside the ring, or there is a double bond being formed on the outer branch. Which is ZZ, which is open. Ibrahim, Jasleen, Zainab, tell me quickly. Which is ZZ alkene, A or B? Zainab, can you see the structures? Ibrahim,
Yes, sir.
ZZ is more branched. Okay. So more branched, what you need to do is you need to circle the double bond. Okay. With both the carbon atoms of the double bond, right? And you need to check how many carbon-carbon groups are coming out. And you will wonder that there is nothing here. Nothing here means there are hydrogens. These are not carbon-carbon groups. That's why which you don't write. Okay. Is it clear? Clear or not? So
Yes, sir.
basically this is alkene, but yeah, this is having two carbon-carbon group. One is this carbon, one is this carbon. is di-substituted alkene. And if you compare this alkene, there are three groups, carbon containing groups, Jesslyn, Zainab and Ibrahim. Do you agree with my point that there are three carbon containing groups in A and there are only two carbon containing groups
Yes.
connected to the doubly bonded carbon atom? So I hope all three of you agree with it,
Yes.
right? So it means this is more branched, more substituted. Okay, more branched, which is having more carbon groups on all its side, is known as ZZ alkene. And this is less branched, often alkene. Less branched alkene is the often alkene. And this is going to form in less amount. And this is going to form in more amount. So this is the major product, this is the minor product. Very simple. Just put the circle on the carbon-carbon double bond. Check how many alkyl groups are there. More branched alkyl group means more substituted alkene is going to be the major product. Got it? I hope this is clear to all three of you. Very simple rule.
Yeah.
But very powerful because a lot of questions are there in every examination. Very basic. Right, Ibrahim? Okay. So this is elimination. Now we are going to move with another type of reaction given by alkyl halide. Reaction of alkyl halide with metals. So metals have what kind of character and what do they give in the reactions? Can any one of you help me out? What may happen with the metal? Metals are what kind of reagent and what they do when they are mixed into the reaction. Metals are electropositive, means they have a tendency to give electrons, okay, donate electrons, right? So metals have tendency to lose electron. You all of us know that very well. For example, if you take sodium metal, it will give electrons. It will itself turn to Na plus and it will lose its electron. Magnesium, magnesium atomic number is 12, 10 plus 2. So that is magnesium is going to give 2 electrons. Aluminium, it is the 13th element. So it is going to release 3 electrons. I hope this is clear. Okay.
Yes.
So you know that metals are electron donors. And in various reactions, we see different roles of metals. together with their valence electrons. So metals are electropositive or they are electron donors. That we know. So what happens with the metal when an alkyl halide? So this is half of the part of the story. The another half is actually we are dealing with the alkyl halides. So alkyl halide, suppose if you take CH3Br, okay, this Br is electronegative. It is having a tendency to pull electron. FCl, Bri, they are in the extreme right hand side of the periodic table. They are electronegative elements. Okay, this is electropositive. This is plus charge. And when the metal comes in contact with the halide ion, magnesium can give 2 electrons to the carbon. Is it clear? So carbon, magnesium will become magnesium plus 2. That 2 electron will come on the carbon. It will form minus. Normally it was plus. It will get 1 electron. It will become just unpaired electron and one more. It will become minus. And Br already break apart as Br minus. So this magnesium, which is giving electrons to the carbon now let the Br to go out and accept the electrons from the magnesium and become carbon minus. Is it clear? Magnesium is metal, it is having a plus charge, and halogen is having, but there is some bond also, so it is not completely minus. I'm going to write it as partial minus, partial positive, partial minus. The magnesium is close to plus 2, carbon is close to -1, halogen is close to -1. Okay, so metals will break the, what is the outcome? Metals will give their electron and they will break the carbon halogen covalent bond and will completely convert it into ionic form, which may have some covalent character. Okay, so this is insertion reaction. The magnesium got inserted between the carbon and halogen, and you get this product which is known as Grignard. It is generally represented in this RMGX. So Ibrahim, can you tell me what are Grignard reagent?
The Grignard reagent, it's formed when an alkyl halide reacts with a metal,
Which metal?
magnesium metal.
Magnesium. Magnesium gives electron. It breaks the
Yeah.
carbon halogen bond, forming a carbon minus and Br minus, and magnesium sit in between those two minus. Because both minus can't come directly in contact with the magnesium is plus 2, so it comes in between. Think it like this, right? Zainab and Jasleen, is it clear? This is known as Grignard reagent, and it belong to the category of, it belong to a class of compound known as organometallic compound. organometallic compounds are those compounds where the carbon atom is directly linked to the metal. Grignard is actually one of those organic compounds where the carbon, example in the Grignard reagent, there is a bond between carbon and magnesium. The metal is magnesium, and this is known as Grignard. Is it clear or not? Okay. This Grignard is going to be very useful. Jesleen, Zainab, Ibrahim, listen to me very carefully. In next chapter of alcohols, in next to next chapter of aldehyde ketones, carboxylic acid, this Grignard reagent is very, very useful. Okay. Is it clear? To mix this magnesium in the presence of ether, it is used to mix them together because magnesium is a solid. So you just have small pieces of magnesium ribbon known as magnesium turnings, methyl bromide or ethyl bromide, whatever the alkyl halide you are taking, heat it in the ether. You will see that the carbon halogen bond is broken and the magnesium comes in between. And you get this compound which is known as organometallic compound. Whatever may be the reactions of organometallic compound, just remember one thing, that the carbon in the organometallic compound carries a negative charge. If you have this thing in your mind, you can do any question of any chapter related to Grignard. Is it clear or not, Ibrahim, Jasleen, Zainab?
Yes, sir.
Just listen to me. What do you, if you have CS3 MgBr, what you will think? You will not bother about anything else. You will think that CS3 is minus. Okay, half of your problems are solved if you know this. Suppose if I write RMgBx, you will think that this R is minus or partial minus. If you have this thing in mind, all your problems will be solved. Suppose if I take benzene ring and MgBr, so Ibrahim, what you will think of this?
What's
How
it?
you will treat it? This one, pH MgBr. How you will treat it? You will not bother about anything else. You will think just this benzene is having a negative charge.
Yeah,
Is it
yeah,
clear?
yeah. Yes, sir.
Suppose if I give you ethyl is this one. Magnesium iodide. So Zainab and Jasleen, what you will think? You will think that this ethyl is carrying a negative charge. Okay, Et minus, this ethyl is having a negative charge because magnesium is plus 2, I is minus. So this ethyl should be minus. If you know this and if you set it in your mind, your upcoming chapters, preparation of alcohol, preparation of aldehyde, ketones, carboxylic acid, all are going to get sorted out very easily. Okay. And why there is a negative charge, that already you know, because metals have positive charge, so carbon will have negative charge. So let me summarize. In organometallic compound like Grignard reagent, the carbon containing group has negative charge. like this. Okay. Here. So all your problems will be solved. So what kind of problems you can get? Okay. Whatever may be the problem, just think of this thing. They will be sorted out. For example, if I give you CH3 MgBr, so you will think CH3 MgBr as CH3 minus. Okay, some partial negative charge. That is delta means partial. Okay. What will happen if you react the CH3 MgBr with water? Any idea? Tell me quickly. What will happen? If the CH3 MgBr is treated with water. So let me tell you the whole funda of organic chemistry, which is very simple. Okay. And that is, okay, you will also realize that organic is so simple. In each reaction, you need to know where you have a positive charge and where you have a negative charge. Got it? So you will be given with two reactants, one positive, negative, positive, negative, positive. Okay. And connect the negative to positive and positive to negative, and that's how you can complete all your reactions. Okay. So we are also following the same thing here, Ibrahim, right? Is it clear? So tell me what can happen.
Yes, sir.
Water you took, you have never seen this reaction before, but now you can tell me if you just think that water is actually what is it, H2 and O, or is it H plus and OH minus, or is it O plus and H minus?
It's
What is
H plus and OH minus.
it? Exactly. So this is actually H plus and OH minus, right? And this is magnesium plus and CH3 minus. Now what to do? Can you help me out? Jasleen and Zainab.
So
Ibrahim, tell me. What to do?
which minus which
OH
minus
minus will
Br
get attached to.
Mg
Yes, exactly. So you will have Mg, Br, OH. Absolutely correct. And where the H plus will go?
it will bond with Br.
This CH3 minus, and that will get connected to H plus. Are you getting my point, Jasleen? Zainab?
So can you explain again?
Yeah, I will explain once again. Suppose if you take water with ethyl magnesium bromide. So what is the charge on this ethyl? -1.
The minus charge.
What is the charge on magnesium? Plus charge. Water means what? Where you have minus, OH minus. In the 11th class, you must have studied that it get ionized as H plus and OH minus. Got it? Clear?
Yes, sir.
Now what to do? Just attach the negative charge to the positive and positive to the negative. Zainab and Ibrahim, are you getting?
Yes.
So what will happen? What you are going to get as the product? Tell me. Ethyl is having minus charge.
CH3.
CH3, CH3, yes. It is going to get converted to ethane. And Mg will get connected to OH. Got it? So that's how you will see your reaction getting completed. Is it clear or not? So when you treat Grignard reagent, you will have lot of reactions of Grignard in each chapter, but the principle is very simple. Grignard R is negatively charged. Okay, whatever the reagent is given, just find who is positive, who is negative. Connect the positive part to the R. So it will become an alkane and MgBr. So nobody is asking you what it is. You need to bother mainly about the organic product. So Grignard reagent, I will write it in the short form. When reacted with water, you are going to end up with an alkane. Is it clear why alkane? Because the magnesium was removed and H plus was connected to R, so you ended up with alkane. So this is in a way a method to reduce and reduction means addition of H, alkyl halide. Is it clear? So let's do one reaction. Okay, we have seen how to convert the benzene to chlorobenzene. Tell me quickly. This in alkanes we took chlorine and sunlight. In benzene, what we need to take? Ibrahim, Jasleen, and Zainab, just try to recall. First of all, I am putting chlorine, so I need to take Cl2. Okay. And what I am removing and what I am putting, I am removing H from the benzene. There are 6 hydrogens which are not written. Be careful. They are removed. One of the hydrogen is removed and connected with Cl. So HCl. This is the reaction. Now my question is, do I need to take sunlight or dark? Do you remember it? Chlorination of aromatic rings, benzene ring, take place in dark. You don't take sunlight because with sunlight you are going to get this. This is hexachlorocyclohexane. Okay, gamaxine, which is used as an insecticide. Right? So you don't take the sunlight. Sunlight you take actually in alkanes. But if you have taken dark, how the Cl is going to break? You need to take some catalyst. Okay. This is with sunlight. Gamaxine or lignin. This is used as an insecticide. Okay. But we are actually talking about this reaction. You need to take, yeah, Ibrahim, tell me. You were there in that class. And Jasleen and Zainab, you might have seen the recorded lecture. So just tell me. Okay, even if it is wrong, no problem. Just all three of you. Tell me what should I take? If I have carrying out in the dark, how I'm going to break the chlorine? Any idea, Brian?
FeCl3.
Yes, I need to take the catalyst.
Yeah,
And what
catalyst,
kind of
FeCl3.
catalyst it is? FeCl3.
Yeah.
This is a Lewis acid catalyst. It actually breaks the Cl minus and leave behind the Cl plus. Okay. So if why you not take the sunlight? Because with the sunlight you get entirely different product. Okay. So this is just a revision of the prior reaction which we studied. Now my question is this: if you react this with Mg and heat it with magnesium, what is going to happen? Chlorobenzene with magnesium, Zainab and Jasleen, just tell me quickly. So you have benzene, you have chlorine. What is going to happen? You are going to put the magnesium in the middle. Got it? Zainab and Jasleen.
Yes, sir.
In short, I can write pH MgCl. Mg got inserted between the benzene and chlorine. Ibrahim, is it clear or not?
Yes.
This is the formation of Grignard reagent. Clear? Now, what I need to do in order to get the benzene again? How can I get my benzene back? Is there any way to remove this MgCl and put H? Tell me quickly. Yes, all three of you. Just think of it, what we were doing. This Mg is having a negative charge. Is it clear or not? Mg is having the negative charge, right? Okay. So what you are going to do? You are going to react it with water. Okay. So I hope this is clear to all of you, right? Any
Yes.
doubts on this?
No, sir.
So when you treat it with water, you end up with an alkane. Okay. There is one more reaction which we studied, which you might remember it, and that is Wood's reaction. Any one of you remember it?
Yes, sir.
Wood's reaction. What that
It's
reaction?
that we'll we yeah we'll take 2 moles of an alkyl halide and add 2 moles of Na, and then we'll get
That's
2 moles of the
yeah, the halide get removed and the alkyl groups
Yeah.
get clubbed together. Yeah,
Yeah.
actually, that Wood's reaction is actually the coupling reaction. Okay, this is the Wood's reaction.
It will happen in the presence of dry ether.
Yes, exactly. Because why dry ether? You are not allowed to take water because sodium can react vigorously with water, and you will not see the reaction which you are expecting. Okay, so if you take the alkyl halides, this is going to be CH3 in the presence of dry ether. Okay, and the NaCl is removed. Okay, this is also the reaction with metals. If you take an alkyl group and one benzene ring containing group, that is aromatic group, or aryl halide or aromatic halide, all are same thing. In the presence of dry ether, I have written the ether as diethyl ether in the short form abbreviated name ET2O diethyl ether. You are going to see that this methyl and the benzene getting joined with each other. So it is a coupling kind of reaction, and this name is Woods fatigue. Just you need to remember the name, otherwise the reaction is very, very easy. Okay, you might have studied in your 11th class. Okay, got it? And suppose if you take both rings to be benzene rings, then it is not called Woods reaction, though it looks very similar to Woods. It is called fatigue reaction. Fatigue reaction is between the two aromatic halides, same as that of Woods reaction, but between two aryl halides. So you are going to get a biphenyl. The name you need to remember because they were asked in the many examinations. They are all same. The byproduct is also same. Everything else is same. Just you need to know the name, and the difference is whether if you take both alkyl group, it is going to be Woods, one alkyl and one aromatic group, Woods fatigue, and if both benzene ring, then it is going to be fatigue, right? So let me end the class, and so bye bye everyone, and I will give you a lot of questions on this in the assignment.